Alright, so I hope this is recording. We are looking at skill packet 3, which is relations and functions, and we're in skill 3E, and 3E is asking us to use two old functions to build a new function. And we're using these two old functions and combining them in what I would think that you would think is a normal way through addition, subtraction, multiplication, or division. Now, right now, we're focusing our attention on addition, subtraction, and multiplication. We're going to do division a little bit later, and then we're also going to introduce a new operation that we can do with functions, and that's called function composition. Alright, so here in problem number 6, it gives me two functions, f and g. Now, surprisingly, it does not ask me to come up with the equation for the new function. It just wants me to come up with the domain of this new function. So I can use the domain of f and the domain of g, the two functions that created this new function, to find the domain. I can take the domain of f and intersect it with the domain of g, and that'll be the domain of this new function f plus g. So to find the domain of f, to find the domain of any function, given an equation, we say it's a set of all real numbers, excluding any values of x that cause division by 0. I don't have any variables in a denominator in f, so I don't have to worry about that. But I do have a variable that's underneath a radical, and we have to exclude any values that would cause us to take the square root of a negative number. So this 4 minus x can't be negative. It has to be 0 or positive. So let's solve this inequality. If we subtract 4 from each side, if I multiply both sides by a negative 1, I have to change the direction of the inequality. And I have the x is less than or equal to 4. If I look at the second function, I don't have a radical in it, so I do not have to worry about taking the square root of negative numbers, but I do have a variable in a denominator. So this x squared minus 1, I need to avoid values of x that would be solutions to this equation that would result in division by 0. So I'm going to factor this. X plus 1 times x minus 1, because I'm afraid that people would mess up and only get a single solution. It's easy to see that 1 squared is 1 and 1 minus 1 is 0, but a lot of students forget that negative 1 squared is also positive 1 and that 1 minus 1 is 0. So this equation has two solutions. Now, they were solutions to this x squared minus 1, which causes problems, which was giving us a 0 in the denominator of this function. So we want to exclude those two values from the domain. So let's come in and draw a number line for the domain of f for values that were less than or equal to 4. But I'm also going to include these other boundary points, these other points of interest, this negative 1, positive 1, and 4. So values that are less than or equal to 4, well, equal to 4, I have a solid dot there, and less than 4, I shade to the left of 4. Now, for let's draw a picture for the domain of G. It was the set of all real numbers, excluding negative 1 and positive 1. Negative 1 and positive 1 are going to cause division by 0, so we want to throw those out of the domain. So here we have all of these other values. So the domain of f plus g, the answer that we want is the intersection of these two sets. So the domain of f plus g, you have to be in both domains to be in the domain of f plus g. So we write down these boundary points, these points of interest. Was negative 1 in both the domain of f and the domain of g? Well, no. It's not in the domain of g, so therefore it can't be in the intersection. To be in the intersection, you have to be in both. One is in the domain of f, but one is not in the domain of g, so it is not here. Now, 4 is in the domain of F, and 4 is also in the domain of G, so 4 is going to be in my intersection. But to the right of 4 will not be, because it's not in the original, it's not in the first, in the domain of F, and it has to be in both F and G to be in my intersection. Between 1 and 4 are both are shaded in the domain of F and the domain of G, so it's going to be in my intersection. And here it's shaded in both, so it'll be in the intersection. And here the going to the left is shaded in both. So here's my answer, a picture of my answer. So I need to describe this in interval notation. So hopefully by now you're getting used to that. We've got the arrow that's shaded, which is negative infinity. We're excluding negative 1, so we do not want a bracket there. We want a parenthesis. And from negative 1 to positive 1, and we're excluding positive 1, so we don't want a bracket there. And then 1 to 4. But see, we are including 4. 4 is solid, so we need a bracket here. So hopefully I said a parenthesis at 1. I've got a little bit of a cold and I'm not feeling that well, so I don't know what I'm saying. But this is my answer for problem 6, and I hope that helps. Talk to you later.